Welcome back to Kubernetes Crashcasts. I'm Sheila, and as always, I'm joined by my co-host, Victor. Before we dive in, I'd like to remind our listeners that if you're enjoying our show, please rate us on your favorite podcast platform. It really helps us reach more people who want to learn about Kubernetes.
That's right, Sheila. Your support means the world to us. Now let's get into today's episode. We're wrapping up our chapter on pods, which is a fundamental concept in Kubernetes. This is the final section of the chapter where we'll be summarizing everything we've covered about pods.
Excellent, Victor. But before we jump into the summary, I have a tricky quiz question for our listeners. Here it is. In a Kubernetes cluster, can a single pod run on multiple nodes simultaneously?
Oh, that's an interesting question, Sheila. It really gets to the heart of how pods function within a Kubernetes cluster. I think our listeners will need to consider the nature of pods and their relationship with nodes to answer this one. But let's not give away any hints just yet. We'll reveal the answer at the end of the episode.
Good idea, Victor. Now, let's start our summary by recapping what a pod actually is. Can you give us a quick refresher?
Certainly. A pod is the smallest deployable unit in Kubernetes. You can think of it as a logical host for one or more containers. It's like an apartment in a big apartment building, where the building is your Kubernetes cluster, and each apartment pod can house one or more people, containers.
That's a great analogy, Victor. So, if I understand correctly, all containers in a pod share the same network namespace and can easily communicate with each other. Is that right?
Exactly, Sheila. Just like roommates in an apartment share the same address and living space, containers in a pod share the same IP address and can communicate via local host. This makes pods perfect for tightly coupled applications that need to work closely together.
I see. Now we've talked about the pod lifecycle in previous episodes, can you summarize the main stages for our listeners?
Of course, the pod lifecycle consists of several stages: pending, running, succeeded, failed, and unknown. A pod starts in the pending stage when the Kubernetes scheduler is trying to find a node to run it on. Once it's assigned to a node and all containers are created, it moves to the running stage. Succeeded and failed states occur when all containers in the pod have terminated, either successfully or unsuccessfully.
That's really helpful, Victor. I remember we also discussed multi-container pods. Can you remind us of some use cases for those?
Absolutely. Multi-container pods are great for several scenarios. One common pattern is the sidecar pattern, where you have a main application container and a helper container. For example, you might have a web server container and a log shipping container in the same pod. Another pattern is the ambassador pattern, where a proxy container handles network connections for the main container.
Those are interesting patterns. I can see how they'd be useful in real-world applications. Speaking of which, do you have any examples of how companies are using pods in production?
Certainly. Many companies use pods to deploy microservices. For instance, an e-commerce company might have separate pods for their product catalog service, shopping cart service, and payment processing service. Each of these pods could be scaled independently based on demand.
That makes sense. Now, I'm sure there are some common pitfalls when working with pods. What should our listeners be aware of?
Great question, Sheila. One common mistake is treating pods as if they're long-lived entities. In reality, pods are designed to be relatively ephemeral. They can be terminated and replaced at any time, so it's important not to store long-term state directly in a pod. Instead, use persistent volumes or external databases for data that needs to persist.
That's a crucial point, Victor. Are there any best practices you'd recommend for working with pods?
Absolutely. First, always use controllers like deployments or stateful sets to manage your pods, rather than creating them directly. This ensures better reliability and easier scaling. Second, make good use of labels and selectors to organize your pods. And third, be mindful of resource requests and limits to ensure your pods get the resources they need without over-consuming.
Those are great tips, Victor. Now, before we wrap up, let's reveal the answer to our quiz question. Can a single pod run on multiple nodes simultaneously?
The answer is no. A pod is always scheduled to run on a single node. It's an atomic unit from Kubernetes' perspective. If you need to run the same application on multiple nodes, you'd create multiple pod instances, typically using a deployment or daemon set.
Thanks for explaining that, Victor. To summarize our chapter on pods, we've learned that pods are the basic building blocks in Kubernetes, hosting one or more containers. They have a defined lifecycle, can be used in various patterns like sidecars and ambassadors, and are crucial for deploying microservices. Remember to treat pods as ephemeral, use controllers to manage them, and be mindful of resource allocation.
That's a great summary, Sheila. I hope our listeners now have a solid understanding of pods and how they function within Kubernetes.
Me too, Victor. And to our listeners, if you found this episode helpful, please visit crashcasts.com and consider joining our Discord community. Your support on Patreon also goes a long way in helping us create more content like this. Don't forget to subscribe and rate our podcast. It really helps us reach more learners like you.
Absolutely, Sheila. Thanks everyone for listening, and we'll see you in the next episode where we'll dive into the exciting world of controllers in Kubernetes.